Good morning. I wanted to do a follow-up on season 2, the first 3 episodes of season 2. Now I'm all confused. Dang it. Oh well, it happens. I spoke into thin air. It's like being double muted on a Zoom call now. It's just ridiculous. You'd think I'd know by now. Anyway, unmuted, back to life. So I wanted to do a follow-up on the first 3 episodes of season 2. In season 2, we've started to work entirely with the state machine and how you can do events and do all the different capabilities and really deep dive into the state machine. So if you haven't catch the first 3 episodes yet, definitely watch those. I'm going to cover some questions and kind of go into some additional scheduling capabilities within the state machine. So one of the first questions that came up was about the book ID. When we have the book state machine, is a book, what is a book? Because there were questions like, well, what if I have 5 copies of a book? So the book within the state machine is to represent a physical copy of a book. So if you have, say, 7 copies of Neuromancer, all of those are going to have a unique book ID. They might be, 3 of them at one branch, 2 of them at another branch, and 2 at another branch. Or it might be different editions of that book or different, hardcover versus paperback, things like that. So this is really meant to be like at the low-level tracking place and actually have the physical instance of the book that's in the library. So when we're adding a book, it's like the librarian checking in that book and scanning that barcode. So yeah, we're at a physical book level and they're reserving an actual one. And that goes into the next questions of, the book state machine isn't actually an aggregate. When you think about domain-driven design and some of the concepts there, you would have higher level concepts in a system such as like a title catalog or, query indexes for things like title, author, edition, subject matter, ISBN, all of the different ways you would search for a book. And, there may be a more complex query model that the application would use. But within this example, we're really at the lower level of actually tracking physical books, reservations, and then ultimately checkouts, which we'll probably get to in the next episode. In fact, in this episode, I may introduce the checked out event, but I don't think I'll go in and build the checkout state machine until probably the following episode to kind of keep it short and kind of not have too much content in one episode. So those were some of the questions that came up, when we talk about, being able to look for a specific book and things like that. So that's really kind of thing, when we talk, some of the other things we might talk about in checkout is, if they, for instance, checked out a different copy, like let's say they reserved a copy at one branch but happened to be closer to another branch and just went and pulled one off the shelf and checked it out, that we would want to cancel the reservation for that same title. And in that case, we may want to have it to where book ID has, title ID or things like that, to where we'll be able to correlate events back and cancel a reservation for another instance of a book when a member checks out the same title with a different branch. So those are a couple things that we might go into in a future episode. But right now, our book ID doesn't even have title. I mean, if we look at our book aggregate, our book state machine in the book state, we have a string title, so I guess we could match it off string title, but ideally we'd want to have that title mapped down to some identifier that we could use. We might just create the event based on title or ISBN so that we can create that event and throw that out. So yeah, that's kind of the Q&A part of the previous things. A couple pieces that I wanted to go to within the sample today, just to kind of finish things out, is I want to create a book checked out event, and I also want to make it so that we can cancel a reservation. So like right now, a reservation just expires after 24 hours, and we can see that within the reservation state machine. And we can see that, if it's reserved, we schedule an expiration event and we schedule that reservation expired. And by default, that schedule is 24 hours. And that's the default delay. So that's kind of where we're at there. When the person reserves the book, you can see that we initially schedule that right there. There's one other piece that I wanted to cover today that was a question that came up shortly after this episode aired, and so I wanted to bring that in as well. So first of all, let's go with a couple different things. Also, within the reservation state machine, you can see if I undo, someone pointed out that I didn't have the reserved state within my instance state. That was just an oversight. I'm using the in-memory Saga repository, which doesn't care. It isn't mapping those ints to actual things. So it isn't doing any table mapping because it's just in memory. So it wasn't an issue, but had we tried to persist this to a database, we would have seen an error of an unknown state. So, that was that case there. Anyway, I've just added that reserved back in there. So one of the things that I want to discuss first, since it's right at the top of mind and it isn't on my list, so I want to cover it, is scheduling. Here I've set the default delay to 24 hours for a reservation, but let's say that we want to actually allow the book reservation, which is the event that we have here, to include a duration for a reservation. So, and let's say that it's optional because we've already produced this event model, it's there, but let's say that we want to do that. And if that's the case, we can put that in here. So let's do a time span duration for the reservation. And here we're giving a full time span. That gives us ultimate flexibility. I mean, if we wanted to put like number of days or things like that, we can always calculate that on the front end and give us a duration. Or we could put an absolute physical expiration, but that's a little time based. So, it's a library. They don't care. If they say you have it for a couple days is great. Have fun. But I want to make that nullable because it's an optional parameter. And this would allow me when I reserve it to say, hey, I can't get there for a couple days. I want an extra bit of time to do that. And what we want to do is we want to allow that duration to be used to change the scheduling period of that so that the message can actually define how long that duration is. Now, because I have a default duration here, I can do this one of two ways. I can just move the default duration to my scheduling statement. So for instance, when I have the book reserved, I have access to the context. So let's change this to, and I believe it is, I think if I do context, context.data.duration timespan.from days 1. And so this extra argument within here, and I'll put it on a new line to kind of clean it up a little bit, this is going to allow us to specify using the message data as input some property from that message, otherwise the default time span. So that's one way I could do it, and I could just take this out. And that's going to let me specify as part of that event when that reservation will expire. And I can put a unit test around that because, again, we want to test our code. So we're going to go to the reservation state machine specs. And I think we have one for when reservation expires. Okay, it's a pretty long one, but that's why we're going to create another version of it. And we'll say when a reservation expires with custom duration, and we'll add that. And we have the book added. We have the reservation requested, which that was our event, right? Reservation requested. We're going to need to add the time span in here as well because we don't have it. And reservation requested is currently used by the book state machine. When the reservation is requested, that's during requested. Okay. Oh, and that's when it's requested. Okay, then we have reserved, and that's when the time span comes out. Okay, so we're just initializing data there. We are going to go to the book state machine now and say when the reservation is requested, we are going to publish. See, we're going to need context.data.duration so that we forward that message property as part of that actual book reserved event. Okay, so now the duration will get there. And now we go back to our test. We're going to put a reservation requested. We're going to set our duration equal to timespan.from days 2. So we're going to ask for a 2-day reservation. And then we're going to assume that it's reserved. Now here's the trick. Previously this test advanced at 24 hours and then checked to see if the reservation wasn't there. Here we're going to advance the system time 1 day, but we're going to check that the book is still reserved because it should still be reserved. Yep. We'll just say it was not still reserved. And then we'll advance the time another 24 hours, which should then cancel the reservation. because we said for 2 days, and 24 hours times 2 is 2 days. So this test will take a little bit of time, but we'll see that we checked it. It was still there after a day, and then it was still there, and then it was gone after 2 days. And so that gives us that test, and we're able to verify that the duration actually lasted longer than we expected. Yeah, so again, you can specify that. It's very easy to change the duration within the reservation just by looking at that value. There is another way we could do that. Let's say we didn't know the duration, but I'm not going to dig into that because that gets into if then else conditions within the state machine. And I really want to save those for a separate episode because they're pretty extensive and not really going to get away from the scheduling part that we have today. So that's how I can set the schedule duration within there. And that kind of makes this version up here kind of superfluous or extraneous or unnecessary. But I think if you don't specify a default delay, it gets mad and throws an exception. So when you're trying to configure the state machine, so you have to have a default value for the expiration. Cool. So now I want to do one more thing. I want to come in and I want to say, okay, let's say we want to cancel a reservation because let's say they just don't want the book anymore. So we're going to have to add a new event to do that. And just like we had the reservation expired event, which just said, hey, this reservation's expired, we would probably have a reservation cancellation requested. Because again, we don't know that it's canceled because they've asked for it to be canceled. And because we're in an eventually consistent system where it comes in, we may have already canceled it. It may have been already checked out. We don't know for sure because the state machine has to make that determination. So we're going to do a reservation cancellation requested, and we're going to move that to another contract. And no, I don't want to add that to Git because I can do it myself. And we aren't going to put the duration in here. I don't even think we need the member ID or the book ID, but we'll just put the reservation ID and a timestamp of the event. In fact, we don't even really need that, but what the heck, we'll just put it there. And we're going to create a test for that. Well, we're going to have to go and put that work in our state machine first. So when a reservation cancellation is requested, and I'm just going to copy that name over for this event. I'm also going to add the correlation in here by reservation ID so that I don't have to hand code that in my state machine. So when I'm reserved, if I get a reservation cancellation requested, it's going to be another one of the events here. When reservation cancellation requested, then I don't have to schedule anything, but I may have a reservation expiration scheduled. And in that case, first I know that I'm going to transition. First I know I'm going to finalize because I don't care anymore. I'm no longer a reservation. But I have an expiration scheduled, and I want to cancel that because I don't want to get that message later on and then have to deal with it. So in this case, because I've scheduled a mention, I can use the unschedule method. And what that will do is it will check the instance state, use that GUID for that token ID, and then send a message to the scheduler to cancel that scheduled message. And that way we want to write scheduling message for the expired reservation to come to us, and then we just go away. Because this was requested, I think I need to also publish this book reservation canceled because I want the book reservation to change. So I also have to publish that. Now this is where I get into writing extension methods for state machines because I don't like to repeat myself. So what I'm going to do is I'm going to come over into this reservation state machine. I'm going to change this type here to reservation state machine extensions. And this gets down into some of the nitty-gritty of how the binding within a state machine works. But I'm going to create one called publish reservation canceled. And the type is going to be my reservation. And this is where it gets interesting. This extension method I stole this from was for a specific message type. But I don't care about the event type, so I'm just going to put T in here. And then I'm going to add T on here, and I'm going to say where T:class. And the event binder that I get in for the reservation, and again, this is getting down into some wankiness, but it makes the state machine a whole lot easier to read, is if I'm able to copy this publish async, because that's what I want to do here. I don't want to do this then, is I want to publish this event and do nothing else. And why don't I have reservation ID? Oh, because it's T, but I know I don't need that. I just need instance.correlation ID, because that's the same thing as the reservation ID. I will just have to assign it to that type. And now I can come up here and just say unschedule, and also publish reservation canceled. And that makes that nice and clean. And I can do the exact, now I can replace this publish async here with the same extension. And now I have that code written once, but I'm able to reference it within the state machine very cleanly. So pretty nice, makes it easier to read, and you can still read through the state machine and say, oh, what am I doing? When either of these things happen, I need to do that. So I want to run all my unit tests again, because I just changed some core behavior. I'm going to go ahead and run those before creating a new one for this new thing. They all passed, great. Either my tests are great and they worked and my change didn't break, or my tests are terrible. But hopefully it's the prior. Now we're going to go back to the reservation state machine, and we're going to do a cancellation. So this one says when a reservation expires, we'll use that as a base, because we want to, but we're going to cancel it. And we'll say when a reservation is canceled, that the book should be marked as available. What we're going to do is, we've done the reservation requested. After we have verified that the state machine is there, instead of advancing time, we are going to put reservation cancellation requested. Same reservation ID, we'll put the timestamp in there. We don't need the book. We don't need to advance the time. And we want to verify that the reservation no longer exists because it finalized and should have deleted. And we want to verify that the book is now back in the available state. So with that test added, we'll run this. And we passed. So if we look close, we can see that, see here, a lot of messages in here. We did a receive of book reservation canceled, so that came in. If we look back, we used the reservation cancellation requested. Okay, great. So we had this is where we produced the message after the state machine was already created and used for book reserved. So that put us in the right state. We asserted our tests. We scheduled the message, but then we went to publish the reservation cancellation requested message. We sent that. The Saga picked it up. It used the existing instance based on that reservation ID. The scheduler says it scheduled the message. Great, that's awesome. Not really relevant here. But we then published the book reservation canceled, which is then going to be received by the book. The book is going to cancel itself. We Saga received. And you can even see that we canceled the scheduled message with the message ID for that, because we had that unscheduled message in the state machine, or that unscheduled statement in the state machine. So that's how we unscheduled it. We don't have to worry about getting a scheduled message down the road. There is timing could come into play here. You could go to ask to cancel it and have that message come back when you're not expecting it, because at this point you've finalized. And because that expiration message isn't handled in the initially statement, it wouldn't know what to do with it. So in this case, I sometimes put this in here, and to handle the overlap of a message still showing up is I will actually say when reservation expired, finalize. And what that's going to do is if I do get an expiration message after the fact, it will just finalize the instance and it will never actually persist it to the Saga repository. So this would be the case where I had a reservation, it canceled or for some reason was finalized before the scheduled message came back in, that scheduled message comes in, it's just going to say, hey, that state machine is already gone, it's no longer relevant, so just, finalize and don't create another instance of it. So that'll eliminate like the weird, oh, this message is not accepted in state initial in your log, or it might just be thrown away. So anyway, that's how to unschedule. That's how to schedule with a customizable duration or a customizable delay until the message is received. And trying to think if there's anything else huge on that one. I don't think so. We've updated that. Let me look through my other list of questions real quick because I thought there were a couple others. Yeah, I don't see anything huge else on there. The one other thing, I mean, if we wanted to go ahead and set ourselves up for the next episode is if I wanted to go ahead and create the checked out event, such as a book being checked out, and that would be like if they actually picked it up to close out the reservation, it would do two things. It would be observed by the book because the book is going to then go into a checked out state. So we could go and add those. But first, let's go to the contracts and add the event. So we have the book reserved. It would probably be very similar to this one. Except in this case, we would say book checked out. And we don't know if it had a reservation ID. Honestly, we don't care because when you go into the library, you might not even care about the reservation ID. You may have the member ID, you may have the book ID, you may have the timestamp. And this may get fleshed out a little more, but right now it's just like, when did you check it out? And who is the member and who is the book? So that we have that. So now if we go to the book state machine and add that, we would come in here and say book checked out. All this checked out, except that might be a really good state name. So we'll probably just call this book checked out. We will need a new state of, we will need a new checked out state. And we don't really care if we're reserved. What we care is we're either available or reserved but the trick is if we're reserved, I guess it doesn't matter. Because if the book is checked out, the book is checked out. I mean, if someone accidentally checks out a book that was reserved from the reserve shelf and it wasn't for them, that isn't really what we're trying to do here. I mean, I guess that gets into the complexity of the domain. But for now, I think what I'm going to do is I'm going to say when during available or reserved, because if a book is checked out, it's checked out. At this point in the model, there isn't anything we can do about it. So when book checked out, we are definitely going to transition to the checked out state because we don't keep track of anything else in our book. That isn't something that we keep track of. The book's state doesn't change beyond just being checked out. We don't keep track of the checkout in the book state machine. In fact, in the next episode, we'll create a state machine for a checkout that an instance is created when the book is checked out. So during available and reserved, which are the only two states we have beyond checked out, when a book is checked out, we will just transition to checked out. We aren't going to keep track of anything at that point. But we want to make it so that the book can't be reserved. Because again, we're only reserved when we're in the available state. We're also going to need to go to the reservation state machine. And it's probably going to be easy to copy this line. Okay. We're going to have book checked out. And so during the reserved, because the reservation would have to be reserved, I guess it really doesn't matter. Because if we're reserved, when book checked out, we are going to finalize the reservation because there is no reason to. We're going to unschedule the expiration because we don't care. We're going to finalize because if the book's checked out, the reservation goes away. But do we care? Because if the, yeah, I mean, this is kind of, where you think about the higher level model, and that's getting into some complexity I don't want to cover right now. But if the book was checked out, but it was checked out to someone who wasn't this member, and that's where I think we're going to get into some event correlation. So let's talk about how we want to correlate this to the state machine. Again, we have to go to our contracts and set up how we want to correlate this one. In this case, I think the default book checked out is going to be the book ID. But because we want this to correlate differently, we're going to have book checked out correlate by, we don't have the reservation, we have the book ID, which means we're going to be correlating with a query. So we're going to have to say correlate by. We're going to have to give two different properties. We're going to have to give the instance dot book ID, because we only know that the book ID was checked out. And from the message, we're going to also have the book ID. But why is that giving me a problem? Right, because this is going to be a query. So actually this is different. This is going to be instance comma context, because we have the message context coming in. And we're going to say instance.correlation ID equals context.message.book ID, but that's got to be book ID, not correlation ID. And this will cancel the reservation because we want to correlate by book ID. Do we need anything else in the expression? I mean, do we care that it's the same member? No, because we're going to look at that differently. That'll give us some conditional things. So like if the book is checked out, but it was checked out to a different member, we may want to bump up an event that said the reservation wasn't canceled, the book that they had reserved had been checked out, and now we want to either find them another copy at the same branch or notify them that their reservation was no longer supported for some reason, like, hey, somebody stole your book, or your book caught on fire and got thrown into a trash bin. I mean, anything could have happened, but we need to point out to the user that that reservation was canceled versus that member checking out the book. So for now, we're just going to correlate by book ID, and we'll put any of the logic within the state machine itself. So here, if the book is checked out, we're definitely going to unschedule that message. But that'll give us an opportunity to kind of dig into how we do if conditions based on whether or not things match the state machine instance. Yeah, so that'll set us up for some fun things to do in the next version, the next episode. I am going to add some reservation state machine stuff, and I'm actually going to add some book state machine stuff since I only have, I still want to verify that the book state machine behaves as it should. So I'm going to say when the book is checked out, should change state to checked out. And what we're going to do here is we're going to verify that the book is there. We aren't going to verify all these consume messages because I really don't care. All I'm going to care is that the book exists in the available state. And then I'm going to publish the book checked out message with the book ID and the timestamp. And I'm going to get my not exists expression, which is just, well, not exist. What is it, book ID? Yeah. Except I want it in a specific state, right? Oh, I want to check that it exists in the checked out state. Because the book will still exist, I just want it to be checked out. And I don't need this. Saga. So my first test is just going to see if the book behaves properly. I don't care about the reservation at this point. I just want to verify that the book indeed does get checked out when the message happens, and it does. Now I want to make it so that my reservation state machine has a similar event of when a reservation is canceled, custom duration, So instead of canceled, we are going to say when a reserved book is checked out, the reservation should be removed. So we're going to add the book, we're going to request the reservation, we're going to verify that we did that, and now instead of publishing the reservation canceled, we are going to publish that the book was checked out, and we're going to verify that the reservation does not exist, but we're going to verify that the book is also checked out. So a lot of cut and paste, but hey, that's what we're doing. We're going to create a reservation, we're going to check out the book, and it passed. We unscheduled our message, we received the book checked out event within the reservation saga, and it matched to that by book ID, and that's what we have. So a lot in there, a lot of stuff around scheduling and canceling reservations, dealing with events in it. The checked out sets us up for the next episode, which we will cover the creation of the checked out state machine and how we're going to keep track of checkouts. And this is, we're going to introduce some cool things like custom state machine activities so that when the book is checked out, we can schedule reminder notices. We'll create an event that's going to actually, within the activity, and we'll do this to kind of show how to create those, to use the settings for notifications to, notify the user that, hey, your book was checked out, it's due on, and, put the due date in there. We won't actually create and send the email, but we'll put the activity in there to show how that would be done. Yeah, so hopefully that was useful. A little more on scheduling, a little more events and correlations and testing. So yeah, thanks for joining. We'll catch you on the next one, and take care.